Oh, you're back. Right. This time we're going to have a look at part number 7, the sheave. It's made out of cast iron, so it'll look a bit different when we give it a material later on. Again, we're given another sectional view of a part. There's a whole bunch of diameters on here, and it's really interesting. This one is easier to see that it's 2 different parts. Okay, it's made up of 2 different bits. You've got this big outer bit with the V in it. You can see that top and bottom. It is the actual pulley, the sheave itself. Inside the sheave, so there's nothing happening in here. This is a big hole. All right, it's for the sheave pin, so that'll get slipped up and in there later on. This is a bush. It tells me that it's a bush. Say in bronze bush, there's this grease groove in the top of it. That's a lot of fun to do. We'll do that in the next video. This video is going to look at just the sheave itself. And we're going to put that hole for the oil. We'll put that in after we have done the sub-assembly and put these 2 bits together and making sure everything lines up properly. All right, so let's get into drawing this thing. How are we going to draw it? I'm going to draw a center line through here, the exact width of it. How wide is it? 99 mil, just like the swivel block we just did in the last video. I'm not interested in this first diameter here. That is the clearance hole for the sheave pin to go into. We're going to start from here. This 75 millimeter diameter, that's that join between the bush and the sheave itself. Out to 112, then up to this one here, 200 for that change in direction. This one here, 250 for another change. 310 mil for the total diameter. 45, 30, 16, they're all widths that I need to know. We're going to use a pretty cool function in this one. It is the symmetry constraint. So that says using a center line running up the middle here, we can make sure that these 2 sides are an equal distance from the center. All right, so let's hop into having a go at drawing this. Back to Inventor. There's our last one. I'm just going to close that. I have it saved already, so I don't need to save that one. Although this next part I do need to save. So, new standard millimeter through our metric library as always. And onto our drawing plane. I'm going to draw this one on my favorite old XY plane. Starting with a center line. So line, center, and it's going to be, make it nice and horizontal, 0 degrees, whatever, 99 long. And press the escape button to finish it. Get it kind of close. A coincident constraint, taking the center point and constraining it with the center there. Lock it in, Eddie, as they say. All right, next. I have a line that runs across up here somewhere. Dimension, how far from the center? What is the diameter of this part here? That's not a bad guess. 75 it is. Okay. Finish that off. Oh, not finish, you silly Billy. Go back in there. Here we are. Right. Now, I can set this first one up really easily. I looked for that dotted line to say, hey, do a vertical constraint here between those 2 endpoints. All right. It should have already done those for us. It's going to make sure that's 99 millimeters long. Right, next, back to drawing lines. I need, from that endpoint, looking for the green dot, this to go up and then head in toward the middle, but I need to stop. You can do the same thing from the other side. You can use your spacebar here to restart drawing a line, going up, in toward the middle, and escape to finish. Now I want those to be horizontally level, so I'm going to pick the center points again. Center point of this line must be horizontal with that one there. What I don't have any control over at the moment is how far apart these are. If I put in a dimension here and say, look, from that point to that point, we should be at 16 millimeters. Yep. Well, but it's not very much in the middle, is it? So then I need to put in another dimension and say, well, from this one to the center point, oh, if I pick up the center point, that's not playing the game very well, is it? Let's try that again. Start with the center point. Center point to that point. There we go. That distance there needs to be, can I move that box? I can. It needs to be that number divided by 2. That centers it up. Yeah. Bit of a painful way of doing it. So we're not going to do it that way. They can. I want to draw a new line. I want this line to be a center line, but it's a vertical center line. Start it right in the center of your 91 one at the bottom and run it up. Doesn't really matter how long it is, but make sure it goes up like that. In the middle here, on the bottom row of the constraints, you have this one, this symmetric constraint. Have a read of it at your own leisure. Basically, what it's saying you need to do is to say, look at this point and look at this point. Now make them centered on this line. So those 3 work together. I'm going to pop a dimension here as well. The height of this line, or the diameter of it. Why didn't that stay on? That line to the center gives us a diameter of 112. Okay. Now, from there we go up. Classic me. I forgot to turn off the center line again. That line there, please, it should not be a, select that. There we go. Should not be a center line. Draw a line from here up. Get it square. Tee off those ends with that horizontal constraint. Yep. Cool. Dimension. What is that one to the throat of that curve? It should be 200. Interesting. Should have come up purple, in my opinion. Oh, I know why it hasn't, because you didn't actually told it it's 16 millimeters wide. But we will. Now, spacebar, escape, spacebar. These ones go out here. Okay, so they need to be horizontally aligned as well. That point and that point need to line up. That point and that point need to be symmetric on this. Ta-da! And we're going to add in a couple of dimensions. This one to this one, that should be 16. We sort of set that up before. The width of this section here, though, I'll just pop that up there. This bit should be 45 wide. Yep. We're given a diameter for that as well. So we're stacking in the diameters here. 250 to, that's not a 2, that is 250. Yeah, then it goes up a bit more to our 310. Sorry, itchy nose there. I'm just going to draw this in. I'm not even going to put it on that center. I'm not even going to line that up. I'm going to line that one up though. All right, constraint time. The 2 tops, the center of that top and the center of this top, well, they should align. Vertically, the center of this point should line up with the center of that. Symmetrically, this one and this one should line up on this center line. Ooh, it's looking better. And horizontally, that bottom point of the V should actually line up with that point there. Yeah. Dimensions. This outer dimension here should be 310. Yep. And the other dimension, the width of this section here was 35. Yay, done. Now there is a radius. Where was that? It was a fillet. So let's change that back to being a fillet. It is a fillet of 10mm radius, and it sits in this corner down here. It doesn't have an arrow pointing to any of the others. The only other one that does actually have a fillet attached to it is in the bottom of the V for the sheave. It's an 8mm radius. Just double checking. Yep. That one should be an 8. There we go. There's the basis of my sheave done. I know it seems a little bit rushed. This is a revolve. It automatically picks it up. There's one profile. There's nothing else for it to choose from. Full rotation. Like I said, this is going to look slightly different because it's out of cast iron. Quite dark. If your resolution is quite good, it will actually come up looking quite grainy as well. We will paint this. We've painted everything else on this one in smooth yellow. Good old smooth safety yellow. Which surfaces are going to be machined? All right. That'll be machined. That'll be machined. Turning it around a bit. That one I would believe be machined, and quite often this is going to be machined in here to get some accurate sizes for cables and so forth to run through. That one and that one there. Right, so we'll make sure they are looking fantastic. We'll make them honed. There it is. Those ones are honed. You could probably do this one out here too if you wanted to, and add that one in. I'm going to, just because I think it looks better that way. And I can see I've missed that edge up here too. There we go. I think we've got it now. Soon be able to tell. Nope, didn't get that one. It's smooth yellow at the moment. And beautiful. There is my single sheave. So we're going to call this one, I'm going to call this one, better put a number on the front of it. Here we go. This is part number 7. 7A sheave. Okay. Have a go at that one. See how you go. And yeah, have a go with that symmetric constraint. It's a bit of fun. See you later.